Good morning. This lesson is for my Honors Integrated 1 class, but before I get started, I want to say I hope everyone is doing okay out there. This is for lesson 12.1, part 2. Let's go ahead and jump right into our goals here. We have two goals. Our first goal is creating a linear equation in slope-intercept form, knowing a y-intercept and a point. Our second goal is using the transitive property to solve linear systems. So this is going to be a pretty simple lesson today. It'll be pretty short. So let's go ahead and jump right into our first goal. You'll notice on the first example, I have a line graph. I know my y-intercept is 0, 2, and I'm going through the point 4, 5. I have the form of an equation written as slope-intercept form, and I'm using f of x. But for simplicity in this lesson, I'm going to not say f of x, I'm going to say y. And that'll hopefully make things make a little bit more sense for our second goal. So again, let me just remind you that m is the slope, and it's how we move, and it's rise over run. And b is where we begin on the y-axis. So right here, we're beginning at 2 on the y-axis. So it's very easy to find b. There it is, it's 2. And to go from here to here, I have to move up 1, 2, 3. So I'm rising 3, and I'm running 1, 2, 3, 4. I'm running 4. 1, 2, 3, 4. So I'm running 4. And so my rise is 3, my run is 4. I can now write my equation. So the equation that represents this is y equals 3 over 4. That's my slope. X plus my y-intercept, which is 2. That is my equation for this line. And if I was to plug in, I would get, if I was to plug in 4, 5, I would get a true statement. The 4 here cancels that 4, so I'm left with a 3. 3 plus a 2 will give me a 5, and y was equal to 5, so it works out. I'll just double check real quick. So 5, that's my y value. Remember, points on the line are solutions. So if I plug in 4, 5, I should get a true statement. This cancels out. I'm left with 3 plus 2, and that's 5 equals 5. So I have a good equation. You don't need to do this as long as you count your rise over run correctly. All right, so let's check off that first goal. Okay. But again, this only works if you know the y-intercept. And remember, the y-intercept has an x value of 0, so maybe you get a y-intercept in a problem, and and so instead of going through our table and plugging in the formula, if you recognize that one of the ordered pairs has a 0 for the x value, just use that as your y-intercept and figure out how far you have to rise to go from your y value to the other y value. That was a 3, and how far you have to run to go from your x value to your other x value. That was your rise was 3, and your run would be 4. Okay, so let's move on to our second goal here. In our second goal, we're going to use the transitive property to solve systems. And you're probably familiar with the transitive property. Let me tell you what the transitive property is first. It says that if A equals C and B equals C, then we can conclude that A must equal B. Basically, if two things are equal to a third, then those two things must be equal. So you know in life that 4 $5 bills is a $20 bill. And you also know that 2 $10 bills is a $20 bill. So 4 5s and 2 10s are equal to the same thing. Therefore, 4 5s must be equal to 2 10s. You know the transitive property. And this is actually a really big idea for next semester. Next semester, we get into geometry, and we're going to make arguments about shapes. And one of the things that we're going to try to do is we're going to try to argue that things must be the same. And we're going to use the transitive property to bring concepts together. So I like the fact that this is at the end of the first semester because it's going to be it's good to see this now because this is going to be a major tool for next semester. All right, so for today's lesson, if we get two equations in slope-intercept form, we can set them equal. This is saying this, and it might not be apparent yet, but let me work through this example And then you'll see that if two things are equal to a third, then those two things themselves must be equal. All right, and this is a real nice way to solve linear systems if the linear systems are written in slope-intercept form. Okay, so I have two lines that we can write the equations of because we just did that right there. And we actually know what the solution is because we can see where they cross. So we already know that this system of equations is going to have a solution at 2, 2. Right? So we know that this is a solution, 2, 2. All right, so let's write our equations. So I'm going to write the equation for this line first. My y-intercept is 5, but I'm going to write it as an ordered pair. Y-intercept is 5. And to go from here, I have to move down 1, 2, 3. So it's a -3 rise and a 1, 2 run. So my equation of the line with the negative slope is going to be y equals -3 over 2x plus 5. Let's write the equation for the other line. Do I have any other colors? I do. All right. So this line has a y-intercept of 0, 1. And to go from 0, 1 to this point, I have to rise 1 and run 2. So this equation is y equals 1 over 2x plus 1. Okay? So this doesn't quite look like this, but it is. If two things are equal to the same thing, then these two things themselves must be equal. So you can actually think of this as A, and this is C, and then this is B, and then this is C. And since both of these are equal to y, we can now say that -3 over 2x, so by the transitive, so -3 over 2x plus 5 is equal to 1/2 x plus 1. Now, this is how we're going to solve this system. What's nice is we've eliminated the y because both the right side of these equations were both equal to y, so we can set them equal to each other. Now we can solve for x. So remember, we've got our 6 steps to solve, right? Eliminate fractions, distribute, combine like terms, get all variables to one side, add or subtract a weighted number, and divide a weighted number. So the first thing I'm going to do is I'm going to eliminate a fraction. I'm going to multiply everybody by 2. You get a 2, you get a 2, you get a 2, and you get a 2. These 2's cancel. I'm left with -3x plus 10 equals 1x plus 2. All right. So I eliminated fractions. Can I combine like terms? I can't put these together. I can't put these together, so I can't do that. I'm sorry, can I distribute? No. Can I combine like terms? No. Can I get all variables to one side? Yes, I can. So I'm going to subtract the 1x to both sides. And now I'm left with -4x plus 10 equals 2. Can I add or subtract a weighted number from the x side? Yes, I can. I can subtract the 10. And now I'm left with -4x, and I hope this is not too low. -4x equals -8. And can I divide away a number? Yes, I can. I can divide away the -4. And I get x is equal to 2. But we know that that was going to be part of the solution because it says right here, they cross at 2, 2. Now, if I was to plug in 2 to either equation, I would get back +2. I like this equation, it's easier, so I'll plug in 2 for my x value. So I get y equals 1 over 2 times 2 plus 1. Those cancel out, I get 1 plus 1, y equals 2. So I get the same answer by solving using transitive property that I would get when I solve using the graphing where they cross. Now, the remaining part of 12.1, you're going to be asked to interpret solutions. I'm not discussing this because this is something that we just took a test on, right? So think about how we had to describe what the intercepts represented. think about how we had to describe what the slope meant. So, you're going to be asked to do the same thing on this one. So, again, hopefully this makes sense to you guys. And we created linear equations in slope-intercept form, knowing the y-intercept and the point. Very easy, we just plug it in. And then since we're dealing with systems, both equations are going to be equal to y, which means we can set these equal to each other, solve for the x, plug the x value into either original equation, find the y value, and we can solve systems by transitive property. So hopefully this makes sense. Have a good day, everybody. Bye-bye.